Hello guys, welcome back to the channel. In this video, we are going to discuss how we can make use of ChatGPT, which is a well-known AI-powered language model developed by OpenAI to get helpful insights for doing geospatial analysis. Now, when I say helpful insights, we are actually going to go way beyond the traditional helpful tips that we would normally get if we were to just look things up by browsing the internet. And instead, with ChatGPT, we are going to ask very specific questions related to the type of analysis that we are trying to perform, and it's going to give us a perfectly tailored answer, or a piece of code in this case, which we could simply copy and paste onto our code editor, and with minimal edits, we would be able to execute the geospatial operations in no time. I'm going to demonstrate these geospatial operations using 6 different examples, and I'll be asking ChatGPT to use Python GeoPandas library whenever I think it becomes relevant. Now, I have done a complete beginner's guide to using GeoPandas library quite some time back, and if you're interested in learning the absolute basics of GeoPandas library, you can click the link on the top right corner of the screen, and you will be able to access this tutorial as well. And I will be making use of a Jupyter notebook to demonstrate this to you guys, but you're free to use any IDE of your choice, given that the required libraries are installed, which you will get to discover as we go along. So guys, without further ado, let's go right ahead and get started with the very first example. So in the very first example, I'm asking ChatGPT to write a code snippet to import 2 shapefiles using GeoPandas library. I'm asking to color the features of the first shapefile in red and the features of the second shapefile in green. And I'm assigning black as the line color for the features of both shapefiles. And at the end, I'm mentioning that I would like to use the Matplotlib library for plotting the data on a Jupyter notebook. So let's just slide this request into ChatGPT and see how it responds. And this is how the interface of ChatGPT basically looks if you are starting out for the very first time. If you head over to chat.openai.com, you will have to create a free account with OpenAI in order to sign up to use ChatGPT. So I'm just putting that request in right over here. And after that, all we have to do is just simply hit enter. And you can see that it's giving us an example code snippet using both GeoPandas as well as Matplotlib libraries. So as you can see, it's basically naming the shapefile 1 as shapefile 1 and shapefile 2 as shapefile 2. And assigning these sample names to the first and the second shapefile was actually done by ChatGPT. That was not done by me, so it was actually smart enough to sort of assign a descriptive name in a way that the user would understand what it's referring to when it's talking about an example code snippet, which is actually pretty amazing. And over here you can see that it's basically writing out the code to create a figure, an access object, and it's assigning a figure size right over here, which we would be able to actually change if we wish to do so. And since I specifically mentioned that I would like to plot these 2 figures side by side, it's basically assigning the columns value to be 2, so that with 2 columns, if you can imagine how a table looks with 2 columns, well, the 2 columns are going to be sort of structured side by side, isn't it? So that's the same principle that we are using over here. So with 2 columns, we are intending to plot these 2 different shapefiles side by side. And it's asking us to use these 2 lines to basically plot the features, the first one in red and the second one in green, with the assignment of this edge color. And here's something that we didn't specifically mention, however it was smart enough to understand that it would be a good idea to have 2 different titles for the subplots. So we can basically go ahead and replace this part of the code with the title that we think is suitable. And finally we can show the plot simply by adding plt.show. Alright, so what I'm going to do is I'm going to open up a Jupyter notebook first and navigate to your working folder. And after you navigate to your working folder, in order to create a new Python script, what I'm going to do is I'm going to click right over here. Under new, we can select Python 3, which creates a new Python 3 notebook basically. Alright, now all I have to do is go over here and simply hit copy code, which will sort of grab this code snippet onto the clipboard, head back to the Jupyter notebook, just right click and select paste, and as you can see, we've got all the lines of code just in this manner. Well, now you might be curious, what exactly are we going to use as this shapefile 1 and the shapefile 2? So just for this example, I have prepared 2 different shapefiles. So here I'm basically opening up ArcMap just for the purpose of showing you guys what these two shapefiles are supposed to be. So I have two different shapefiles. So the first one is called region of interest 1 and the second one is called region of interest 2. So if we quickly have a look at the region of interest 1, the extent of the region of interest 1, it's basically a shapefile that encompasses this lake right over here. And if you would like to know the extent of the region of interest 2, well, this is how the region of interest 2 basically spreads out. A part of it is basically crossing over to the spatial extent of this lake as well. So this is just for your information, just so that you will have some sort of an idea what kind of shapes or what kind of polygons that we are dealing with when we import this into our Jupyter notebook later on. And at the same time, if you're wondering about the actual files pertaining to these two different shapefiles, so over here you can see the set of different files which basically makes up the region of interest 1 shapefile, and right over here similarly you can see the set of files which makes up the region of interest 2 shapefile as well. Now one thing to keep in mind is that when we are getting code snippets like this from ChatGPT, chances are we might not be able to execute this code immediately because there's actually a limitation when it comes to how much we can tell ChatGPT. Not that it cannot actually deliver if we were to be very specific to the level where we also indicate the folder in which we keep our shapefiles as well. But I don't think it's not really necessary to be that specific, because when it gives us a generic path like this, what we can do is we can basically replace this path or supersede this already given path by the actual path of the shapefile that we are supposed to use for our own analysis. So in this case, what I have to do is I have to copy this path and direct it to the region of interest 1 shapefile, and similarly for the second shapefile I would have to use this path and direct it to the region of interest 2 shapefile as well. So that's what we are going to do. So I'm going to replace this and add a backslash and name my first file as region of interest 1.shp. However, since I'm using backslashes over here, I would have to add a simple R. Or if you don't want to use this R, you will have to change these backslashes to basically slashes. But I don't want to do that, so I'm just going to retain this as it is and just add a simple R over here, so that it's going to recognize that I'm referring to a specific path. And similarly, I'm going to copy this entire path and paste it over here. But for the second shapefile, instead of region of interest 1, I'm just going to add region of interest 2. And when creating the figure and the axis object, I don't really have any amendments that I would like to do, so I'm just going to leave this line of code as it is. I think we are good to go when it comes to these two lines as well. And just as the two titles, well, we'll just leave this shapefile 1 and shapefile 2 for the time being. And what we can do is we can basically do a secondary run and try to change these two titles if you really wish to do so. So the rest look good to me, and to test this out, what I can do is I can just simply click run over here, and just like that you can see that it basically displayed the shapefile 1 and the shapefile 2 side by side exactly as we intended. And just like what I mentioned, if I wanted to change the titles, well, I can simply pass a title called region of interest 1, and for this we can make it to be region of interest 2. And after that, if I click run again, you can see that now it basically displayed the two titles just like this. And over here on the X and Y axis, what it's basically showing us is the longitude and latitude information, and this shapefile has a UTM-70 north projection. So these are the coordinates basically that are corresponding to that particular coordinate reference system. So it's pretty convenient to have those coordinate information displayed like this as well, especially if you want to know whether these two shapefiles are supposed to be spatially located far apart from each other or whether it's supposed to be in the same region and whatnot. You can have an initial guess simply by looking at these numbers whether it's basically falling on the same region or not. Alright guys, so the next thing that I'm going to do is exactly that. I'm asking ChatGPT to amend this code that we have right over here in a way that we plot the second shapefile on top of the first shapefile. just so that we can know whether it's really intersecting each other or not. Well, we already know that it does intersect just because I showed you guys the extent of these shapefiles using ArcMap. However, let's just imagine for a second that we didn't really pass through that step. We have no idea whether these two shapefiles are basically crossing over to each other's boundaries or not. So I'm heading back to ChatGPT and I'm asking it, alright guys, so I'm asking how can I amend the above code snippet to plot the second shapefile on top of the first shapefile. And we don't really even necessarily need to refer to the shapefiles as shapefile 1 and shapefile 2. ChatGPT is smart enough to understand when we say the first shapefile and the second shapefile that we are referring to these two in the correct order. So let's just hit and see what kind of a response we're going to get. So it's basically repeating the same steps that we had previously. So one of the key differences in the two code snippets is that over here we don't have that encalls argument, because in this modified code, two different shapefiles are basically plotted on top of each other in a single subplot, as it states right over here. So it's quite handy in the sense that it's basically giving us a small description following the code snippet explaining what it has done. And something quite important, when we plot the first shapefile and the second shapefile on top of each other, we no longer can assign two different unique titles. So in that case, you can see that it got rid of one of these ax.setTitle lines of code, and over here it's basically justifying the reason for that, because now we're going to set a common title instead of just setting two different titles for the two different shapefiles. Well, what I can do is I can basically copy this code and I can paste it over here temporarily. And I think what I can do is I can basically copy this entire part, especially considering that over here we don't have the axis 1 and axis 2, just like what we have right over here, because now we are plotting everything into the same plot. So just copy that part out, and what we can do is we can just replace this whole thing. And is there anything that we think that's going to require an amendment? I think we can change the title over here, and I can just simply hit delete to get rid of that code snippet. And as the title, I would like to pass a title called Region of Interest 1 and 2. Alright, now what we can do is simply run this code snippet and see how it looks. And just as we expected, you can see that it basically plotted the shapefile 2, or the feature of the shapefile 2 on top of the feature of the shapefile 1. And we can always play around with the figure size. As I told you guys, let's say if we wanted to make this to be 20 and this to be about 15, we can rerun the command, and now you can see that it's basically expanding the extent. Well, I think it's a bit too big, so let's set this one to be 15 and this one to be about 10. Yeah, I think this is good enough for me. Now, before I move on to the second example, I'm also going to do an additional step, and I'm asking help from ChatGPT to amend this code further in a way that we change the transparency of this shapefile 2, just so that I could see shapefile 1 behind that, and that'll give me sort of an idea about the extent of the shapefile, of the features of the shapefile 1. Because when we plot the shapefiles on top of each other, I have no idea what is the spatial extent of this red color feature in its northern part, because it crosses into this green color shapefile and it's basically completely obstructed by this fill color. So I would like to increase the transparency of this shapefile too. So what I'm going to do is I'm going to ask ChatGPT the directions to increase the transparency of the second shapefile. So how can I increase the transparency of the second shapefile so that I could visually see the extent of the first shapefile as well? And just like that, you can see what it actually added additionally compared to what we had before. It basically passed this argument called alpha, which basically controls the transparency, and sure enough, it didn't really forget to emphasize on that particular change right over here as well, just so that we would know exactly what kind of a change that we are supposed to do. So I'm just going to copy this alpha equals 0.5, basically pass it as an argument right over here, rerun the code, and sure enough, we can see that the transparency has increased, and now we could see the first and the second shapefiles and the common region where it intersects each other, which is supposed to be this area right over here. All of these lines of code, we are actually able to find it if we were to do a simple Google search. However, what's going to be very efficient when we use ChatGPT as a tool that can increase our productivity is that we can be very specific in what we need, and it can save a whole lot of time that we otherwise would have spent just reading unrelated stuff on the internet just to get to the point that we're trying to make. But when using ChatGPT, we can be very specific to the T, and it can guide us in the right direction without having to spend a whole lot of time doing unnecessary and unrelated things. Alright, with that, let's move on to the second example, example number 2. So in the second example, I'm asking ChatGPT to write a code snippet to intersect the first and the second shapefiles and add an additional field to the resulting GeoPandas geodata frame to calculate the areas of the polygon features. After that, I'm asking ChatGPT to export the resulting geodata frame as a CSV file or as a pandas data frame that we can basically open up using Notepad or Microsoft Excel or a software like that. So if you come back to the plot that we created at the end of the first example, you can see that we have this region of interest or this common ground that belongs to both region of interest 2 as well as region of interest 1. In the second example, what I'm asking ChatGPT is the line of code that we need to use to basically intersect these two different shapefiles and get the extent of the polygon that's basically common to region of interest 1 as well as region of interest 2, and calculate the area of that and export that as a CSV file. So what I'm going to do is I'm going to head back to ChatGPT, and over here I'm just going to basically slide in my request again. Alright, let's hit enter and see what sort of a response we're going to get from ChatGPT. Alright, now let's go line by line and see what it's doing. So over here you can see that it's basically asking us to import the two shapefiles again, which we already covered in the first exercise. And now it's running basically an overlay operation, but if you were to be specific, it's basically an intersection operation between the first shapefile and the second shapefile. And it's basically making use of the GeoPandas library to do that. And after that, it's basically including a new field called area, or a new column. If you were to actually refer to the attributes table as a table, it's basically adding a new column or a new field called area. And this is how it's basically calculating the area. So over here, it's referring to the geometry column, which we will also see as we go along what this geometry column refers to. In case if you're not really familiar with why we have a geometry column in this intersect GeoPandas geodata frame, and what this dot area does is it's basically calculating the area. And finally, it's exporting this intersect GeoPandas geodata frame to a CSV, and when you do this, it's basically losing all of its geospatial properties, and over here we can specify the path to which we would like to export this file. Alright, if that was too much information, let's dissect this part by part. So what I'm going to do is I'm going to basically use these two blocks, and I'm going to use a new line over here, and sure enough we are going to replace these two lines by the actual path. And now if I run the code you can see that we didn't really get any error messages or anything. And now for the first time, we are going to actually explore the attributes table of the two different shapefiles. So if I would like to view how this shapefile 1 looks, what I can do is I can maybe move to another line and type shapefile 1. So let's go ahead and run this cell, and this is how the attributes table of this shapefile 1 is supposed to look. To be frank, we no longer call this an attributes table. Once we import this into Python using GeoPandas, we need to start calling them GeoPandas geodata frames. Well, if you were to be pedantic, but yeah, that's the correct term that we're supposed to use. So when we look at this GeoPandas geodata frame, you can see that we have two different columns. So the first one is called name, and there's this geometry column which basically gets created every time when we import shapefiles into Python as a GeoPandas geodata frame. It's basically a special column that embeds the geometrical properties. Without this column, we wouldn't really be able to plot this shapefile 1, because this column is the place where the geospatial properties are basically saved. It wouldn't really know how to draw a polygon object if it didn't really have this geometry column. So that's a bit of extra information. So let's get rid of this and head back to ChatGPT. And now I'm going to copy this line of code and edit over here. And instead of the name intersect, I'm just going to modify it slightly by saying intersected object. Just like that, so that it would be clear we are not referring to the process of intersecting. We are referring to the object. We are just passing a name over here. And if we run this command, and if I want to inspect this intersected object, if I run this cell, now you can see that this intersected object basically has properties from both name1 and name2. And if I want to visually see how this intersected object basically looks, what I can do is I can ask that from ChatGPT as well, but it's not that significant. All I have to do is just pass a dot plot over here, and if I run this cell, it's going to basically create a plot which corresponds to this intersected part. You can see that this southern boundary is basically the boundary right over here, and this part in the west is basically the boundary over here, and the remaining part has been taken from the extent of basically the shapefile 1, as we can see right over here. And just so that we don't forget, let's copy this and see how the attributes table or the GeoPandas geodata frame looks. So you can see that currently we have three different columns, name1, name2, and in this line what we're trying to do is we're basically trying to create a new column called area. So over here we will need to change the name as well to intersected object, and the same goes to here as well. And now if I select this cell and run, and if I go over here to this cell and run it as well, now you can see that it's basically having a new column called area. Now since by default it's using meters as its units, we are getting this area in square meters basically. But if you wanted to, let's say, convert it into square kilometers, because the numbers look too big over here, you can see that it's basically going to 10 to the power 8. What we can do is we can simply divide this by 10 to the power 6 and rerun this cell and select here and rerun this cell as well. So over here you can see that it's perfectly coming up to be about 499 square kilometers, the extent of this intersected object. And finally, how do we export this? We can add another line of code and specify the name of the shapefile over here, or name of the GeoPandas geodata frame over here to be intersected object to CSV. And over here we can set the path as well. And the name of the CSV file, I can name it as intersected object.csv, and we'll see what happens if you run the code. So sure enough, you can see over here there's one CSV file called intersected object, and if I right click and open that up, this is how it's going to look. So we have, well, these columns name1, name2, which indicates that the area, the common area, has parts from both region of interest 1 and region of interest 2. And the geometry column wouldn't really be necessary for us, so we can just right click and delete. and we have the area over here. Now you can see that it's just one line or one row, but if you're doing this using complex shapefiles which has maybe thousands of different objects, the parts that get intersected will be completely different and the numbers will be way higher than this. So in such a case, it would be quite handy to have them exported into a separate CSV file like this. But just for the demonstration purposes of this tutorial, I'm basically using a very simple example which has just one row. However, the principle of doing things or the order of doing things remains to be the same, so that you can extrapolate the skills that you're learning from here into your own different specific cases and see how it goes from there. Alright guys, so that's about it for the example number 2. Now let's move on to the example number 3. Alright, so example 3 goes like this. If the first shapefile is a point shapefile which contains locations of ATMs, and if the second shapefile is a point shapefile which specifies the location of an office, write a code snippet to import and plot both shapefiles using GeoPandas library. And I'm specifying that I would like to have the ATMs in blue color and the office in red color. And I'm also specifying that the marker size of the office is required to be twice as big as the size of the ATMs. And after that, I would like to calculate the distance from the office to each ATM, and I would like to put it into a table and export that table as a CSV file or as a pandas data frame. Now you can see that the complexity of the problem compared to the previous case might be a bit high, because when we specify the problem, you can see that we are actually being more specific when it comes to what we need to do, and now we're dealing with points instead of polygons as compared to the previous 2 examples. And before we proceed with generating the code snippet using ChatGPT, I would again like to give you some sort of an overview of how spatially these points are supposed to be. And again, I'm using ArcMap just for the demonstration purposes. You don't really have to worry about this part at all, except for understanding what sort of a dataset that we're actually dealing with. So as you can see over here, I have, I guess, about 18 different ATMs, which are marked just like this in blue color. And I do have one office location called ABC Electronics, which is marked in red color right over here. So the objective of this exercise would be to generate a code that can calculate the distances between, let's say, ABC Electronics and ATM 1, ABC Electronics and ATM 2, ABC Electronics and ATM 3, and so on. Well, if you were to do a manual calculation using a software like this, let's say for the distance between ABC Electronics and the ATM number 1, we're supposed to get a distance of about 2.5 kilometers. Well, I'm not being very precise over here. However, when we use GeoPandas to actually calculate these distances, we're going to get exactly the precise values when it comes to the distances between ATM 1, ATM 2, ATM 3, ATM 4, ATM 5, and so on. And if you try to see visually how these shapefiles look, so over here you can see the files that basically make up the ATM's shapefile, and similarly we have the files that basically make up the office locations as well. And since this example is basically not related to the example 1 and example 2, what I'm going to do is I'm going to name this as example 1 and 2, and I'm going to create a new notebook. And for now, let's call this example 3. And what we can do is we can basically head back to ChatGPT as well. And again, since what we're trying to do is not really related to the conversation that we were having with the ChatGPT until now, what we can do is we can actually open up a new chat and simply specify our request. Alright, so that's going to be our request. After that, we can simply hit enter to see what sort of a response we are going to get from ChatGPT. And as you can see, it's basically writing out the code for us. It's using pandas this time, in addition to the GeoPandas library. And first of all, what it's doing is it's reading in the 2 different shapefiles. So even though the name of the shapefile that we specified in our own case was ATMs, You can see that it's again assigning a very descriptive name for the shapefile so that we will know exactly which shapefile it's referring to. So it's creating a shapefile called ATM_shapefile and followed by another shapefile called office_shapefile. And when you import these shapefiles into Python using GeoPandas library, it becomes GeoPandas geodata frames. So it's somehow adding this extra line of code to basically convert this office shapefile into a GeoPandas geodata frame for the second time, which I don't think is actually going to be necessary, to be honest. However, they're just sliding this code in. And what's going to be important for us is that it actually understood that we wanted the marker size of this office GDF to be twice as big as the marker size of this ATM shapefile. So over here you can see that as an example it assigned 20 as the marker size and this one is double of 20. So it actually understood our command along with the requests when it comes to how I would like them to be colored. So this one will be in red and this one will be in blue. And after that it's basically doing the computation of the distance between the location of the office and each of the different shapefiles. And over here what it's doing is basically adding a new column or a new field called distance to office to this ATM shapefile, and it's calculating the distance between each of those different ATM points with respect to this geometry column of this office shapefile. So we'll actually get into this in a bit of a detailed way when we're actually executing this code. And finally, it's exporting that data table into a CSV file. So over here, it's basically assuming that both the shapefiles will have an ID column to identify each point, which might not necessarily be the case, but it's always good to have this kind of a footnote so that we know exactly what we have to deal with, and it's asking us to basically adjust this ATM distance table if we happen to run into issues due to not having this ID column. So we'll get to that once we reach that point as well. So as a starting point, what I'm going to do is I'm going to copy this code and paste it right over here. And sure enough, we are going to have to change the paths to this ATM shapefile and the office shapefile as well. So the first one was called atms.shp, and similarly the second shapefile was called office locations shp, and I think we don't really need to change anything in these two lines of code because it's basically assigning the color and the marker size, and again for some reason it's basically writing this again into a new geodata frame called office_gdf, which I don't think is actually an absolute must. However, we'll just go along with that. So what I'm going to do is, before we explore these two lines of code, I'm just going to comment these two lines out and this line as well, so that this won't be sort of executed when I run the code snippet. So let's run this one and see. And over here you can see the first plot is basically showing the location of the office, and the second plot the locations of the ATMs. Well, just because I was not really specific when it comes to asking ChatGPT to provide the code to plot both of these shapefiles on the same plot, it just plotted these two as two different plots. However, that's totally fine. In case if you wanted to amend the code to plot both of these shapefiles on the same plot, you know how to do that, especially if you were to refer back to this code snippet of example 1, and you will be able to amend the code accordingly. However, for this example, we have a proper understanding of where this office location point is actually supposed to be. And before we go ahead and activate this line of code, let's see how the attributes table of each of these different shapefiles actually look. So if I open up the office GDF, so this is how it looks. You can see that there is one column called name, and the name is ABC Electronics, and we have this special geometry column as well. And similarly, if I were to explore this ATM shapefile, GeoPandas geodata frame, you can see that there is one column called name of AT. Well, actually it's supposed to be name of the ATM. And over here you can see that each ATM has its unique name, starting from ATM 1, 2, all the way until ATM 18. So each of these different points do have its unique ATM ID name as well. Obviously, in addition to this special geometry column, which specifies the X and Y coordinates so that it knows spatially where it's supposed to be when we talk about a geospatial plot like this. Alright, now what I'm going to do is I'm going to activate this line of code, and what this does is it's going to basically add a new column heading called distance to office to this ATM shapefile. So right now you can see that we have just two columns, name of ATM and the geometry. So once we execute or once we run this line of command, what it's going to do is it's basically going to add a new field called distance to office, maybe somewhere over here, and it's taking the ATM shapefile and it's calculating the distance from each of these different 18 points to the spatial location of this office shapefile, which is specified by this geometry column right over here. So when we say a distance calculation, what we're actually referring to is basically the distance, the spatial distance between this XY coordinate and this XY coordinate, and that's going to give us the distance between ATM1 and ABC Electronics. And similarly, if I were to calculate the spatial distance between this point, which is given by this XY coordinates, and this point, which is given by these XY coordinates, that's going to give me the distance between ATM2 and ABC Electronics. And similarly, what it's going to do is it's going to perform that operation for all the different 18 points, and it's going to create a new column on the right side and probably stack it over there, saying this is the distance between the ATMs and the office location, which is ABC Electronics in this case. Alright, so let's run this code snippet, and after that we would have to run this one as well. And sure enough, you can see a new column appears right over here, which is basically the distance calculation between all the ATMs and the location of ABC Electronics. If you guys can recall, when I calculated the distance using ArcMap, just to demonstrate to you guys at the beginning of example 3, I can recall I got something which is close to this number. And finally, let's head over to this part and see what we have to do when it comes to exporting this table as a CSV file. So if I activate this first line of code, you can see what it's going to do is it's basically creating a new variable called ATM underscore distance underscore table, and it's taking this ATM GeoPandas geodata frame, and it's basically stripping off all the unnecessary columns. Let's say if you had multiple columns, what it's doing over here is basically manually specifying just the number of columns or just the column IDs that we would like to have in our final exported product, which is going to be this ATM distance table. And since we do not really have a column called ID, what I'm going to do is I'm going to copy this name, because in the final output I would like to have this column which specifies the ATM ID as well. So I'm just going to replace this with that, and I would definitely like to keep this distance to office column as well, because that way I would be able to see directly what is the distance between each ATM and this ABC Electronics office location. And finally, this line of code would export that to a CSV file, and if I don't really specify the entire path, this file will get exported to the location where we save our Jupyter notebook. However, if you were to add your own path, you can actually export this CSV into a folder location of your own. And over here, it's basically deactivating the index, which we don't really need. However, for some reason, if you would like to still retain this index column, you can leave this index argument to be true. But if you specify the index argument to be false, that'll sort of disappear in the exported file. Alright, now let's execute this command. If I head to the folder where I have saved these Jupyter notebooks, you can see that this file basically got created ATM underscore distance underscore table. So let's just go ahead and open that up. And as I told you guys, you can see that this index column no longer exists. Instead, what we have is this name of ATM and the distance to the office as well. Pretty cool, isn't it? So before I wrap up this tutorial, I would like to sort of extend this example 3 by specifying a case where we have 2 office locations instead of just 1. And if I were to visually show you guys how such a case would look, this is how it would potentially look. So you can remember that in the previous example, there was just one location called ABC Electronics, but now you can see that it has 2 different locations. If you were to explore the attributes table, you can see that now we have 2 different features just like this, ABC Electronics and another feature called XYZ IT supplies. So what we can do is we can actually advise ChatGPT on this new circumstance and see what sort of a response we can get when it comes to doing the same sort of an operation in calculating the distances between the locations of the two offices with respect to the location of each ATM. So what I can do is I can head back to ChatGPT and say, what if the office shapefile contains two features instead of just one? In that case, how do I amend the code? Let's just pass this sort of a request and see what kind of a response we are going to get. Well, it's saying that if office shapefile contains multiple points, you can modify the code to calculate the distance from each ATM to the closest office location. Well, in this case, what it's doing is it's basically finding out the closest office location. So I think we might have to be a bit more descriptive when it comes to our request, because what I would like to do is in the final table have 3 different columns, and the first column obviously can be the name of the ATM or the ATM ID, and the second and the third columns should basically tell me the distances between the offices and the ATMs separately. So let's just refresh this request a bit to be a bit more specific. Alright, so I have refreshed my request. I would like to calculate the distance from each office to the ATMs. The table at the end should contain the ATM ID, distance from office location 1 to the ATMs, and the distance from office location 2 to the ATMs. Alright, let's hit enter and see what sort of a response we get. Alright, this looks like what I was looking for. Over here you can see especially it's creating a new GeoPandas geodata frame called distances, and basically sliding in the information of the ATMs as well as the distances corresponding to Office 1 as well as Office 2. So what I'm going to do is I'm going to basically copy this code snippet and paste it maybe in a new cell, and we can get rid of this and sort of slide this part in like this. And as I mentioned to you guys, what it's doing is basically it's creating a new GeoPandas geodata frame, an empty GeoPandas geodata frame called distances. And into that distances GeoPandas geodata frame, it's first assigning a new column ID called ID. And in the example code, what it's basically looking for is the ID of the ATM. And since we know that we don't really have a column name called ID, but instead we have one called name of AT, which is giving us the name of the ATM, we can simply slide that in as well. And in addition to that, it's also adding 2 more columns. The first column called distance to Office 1 and the second column called distance to Office 2. And when it comes to referring to the geometry element, you can see that for the distance to Office 1, it's searching the distances from each ATM location to this 0th element, which basically gives the location of the first office. So this is basically the item at index number 1 of the office shapefile, and that's going to be the information of office number 2. And with respect to that, it's doing the calculation of the distances of each of the different ATM locations. So what we can do is we can basically execute this code snippet, and I would be interested to see how this distances GeoPandas geodata frame look. So let's run this cell, and over here you can see that now what we have is basically 3 different columns. The first column showing the ATM ID, and the second and the third columns basically showing the distance to Office 1 and distance to Office 2 from each of these different ATMs. And if we head back to our original folder, we would be able to see this new ATM distances to offices CSV file as well. Let's go ahead and open that up, and this is how that file basically is supposed to look. We have the 3 columns and the distance information just like this. So pretty handy in getting stuff done using ChatGPT, isn't it? So as you can see, in certain cases it's still going to need some human input. It's not able to do everything completely by itself, so that's why this is going to be a good tool that kind of elevates your productivity if you have some sort of a base knowledge. And if that's the case, if you know exactly what to search for, this is just going to boost your productivity exponentially, I would say, which can make your life much easier by being able to get stuff done without having to read through loads of information if you were to just browse the internet in the traditional way. Alright guys, so that concludes the example number 3. And now we'll head to example number 4 and see what sort of a geospatial analysis we are going to talk about in example number 4 in the next part of the tutorial.